Welcome. In this part, we will talk about the HTTP request matching in Mockintosh. So let's start with path matching. You can define variables as path segments through templating, such that this path is translated into a regular expression that matches everything in the third segment, which you can see through the verbose flag of Mockintosh. So a request with path /example /path /sum-value /last segment, we get a my variable is captured sum-value response. For a response like /example /path /sum-value /different, you would get a 404 as the response, since all the segments except the third one are static values and the last segment is not matching to the requested path. You can also use multiple variable declarations in a single segment. Such a usage is automatically translated into the proper regular expression capture groups. So a request like get /example /path /value1 -middle -value2 /last segment, you would get x is value1 and y is value2 as the response. It's possible to define custom regular expression path matching rules using the regex template helper. For example, this path only matches to the requests if the third path segment is a digit. Otherwise, it returns a 404. Note that using the regex helper in any places that request matching through templating is possible. The default HTTP method for an endpoint is get. You can choose the HTTP method for the endpoint using the method field. In this example, there are endpoints to match get, post, put, and patch HTTP methods for the same /example path. But if you request delete /example, then you get a 405. If query string parameters are defined under the query string field as key value pairs, then the request matching mechanism expects to have those proper key value pairs in the query string, otherwise it responds with a 400. So as you can see from this example that there can be multiple definitions of a path with the same HTTP method, but different query string expectations, such that Mockintosh tries to match one of those alternatives of the same endpoint and responds with a 400 in case of a match failure. The static value endpoint expecting to have my value as the query string parameter 1 and my value only, while the first alternative endpoint expects to see two additional query string parameters, parameter 2 and 3, which should match accordingly in terms of the regular expressions. For the second alternative, however, there is only one required query string parameter, and it's the static value, another query string. Similar to query string matching, if the headers are defined under the headers field as key value pairs, then the request matching mechanism expects to have those proper key value pairs in the headers. Otherwise, it responds with a 400. It's also possible to pass any component of the HTTP request to response headers using the request object. You can even set the cookies using the reference in the request as shown in the example. The body field can either be a plain text or a JSON schema, or a list of URL encoded or multipart key pairs, such that the request body have to match the description in the body field. Similar to query string matching. If there are no matches, then the response is 400. In this example, body is a plain text that should start with expected val prefix. Otherwise, the request is not matched. In this example, the body field is detailed into a list of URL encoded or multipart key value pairs. For the first endpoint, these three URL encoded form data parameters are expected to match to happen, and for the second endpoint, these three URL multipart form data parameters are expected. In this example, the body field is a JSON schema, and it describes a required field for the incoming JSON payload, and it matches only if the request body, which is a JSON string, contains the sum key field. You can find the examples given in this video at the description. I hope that you liked it. See you later again in a new video. Take care. Goodbye.